10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Hey everyone, welcome to the stream. So, those of you who are new, if you are joining us, my name's Galoptics, and today we're going to be designing a portrait lens that's around, let's say, 85 millimeters in EFL, and yeah, we're aiming for f2. So yeah, there's not much more to say. I've got some other specifications written on here and in my Discord chats with Andy to make sure that everything stays reasonable. And let's just go ahead and get right into this. Alright, so the first thing I'm going to do is I'm going to create a new lens. And we're just going to start entering everything we're looking for. So I can start with either the entrance pupil diameter or the F number, which is one of the things that we specified up above us. So we said F2. Sorry, set to F2. So we're going to keep going forward. Now, next thing we need to look at is, the spectrum, the wavelength spectrum, because of course light isn't just one wavelength, it's multiple wavelengths. Actually, I think I'm the only one watching. Hold on. Alright, so I'm just going to use DFC because that's the normal one everyone uses when they're designing lenses like this. Next, I want to reference green, which is 587. I'm curious of... Alright, field. So we're actually going with real image height on this one. So what this means is that... So fields are essentially different spots that all the light will focus down into as it's running through its design. And by choosing a real image height, what we're doing... I'm going to turn this audio down a little bit. So what we're doing by this is, by defining the real image heights, we are defining where the image will actually reach its final point in terms of the actual film itself. So that will help us out later on, but for now I just want to get it to look decent on axis. We're gonna just call this collaboration, because that's what this is. I was the only one watching. Yep. Congratulations. We have now started a new lens. this is a part of the project where I just kind of rearrange everything. Get everything the way I want it to. So front surface, back, stop, front, back, blank. Blank. And then we want to do blank. Dummy 1, dummy 2, since it won't let me have multiple names. Okay, so right, this is where everything's gonna get a little more complicated than most of my normal designs, so I'm excited for this. So normally what I would do when I get this is I would say, all right, keeping everything spherical, what we're gonna do is we're gonna just introduce some power into everything. Go ahead and introduce this thickness. Oh, these are in inches. 0.125. And then we're just gonna go with our classic NBK7 glass. So for those of you who don't know, the common glass type that everyone uses is BK7. That's what you would find in your normal glassware. I actually have a glass here. Give me a sec. Okay, so this is a shot glass from the glass producer Shot. This should be made out of their NBK7. This is your classic glass type, and what we'll be assuming Andy's glass to be, since generally most glasses or common glasses have a refractive index of 1.5 and have a decent dispersion. So that's the assumption that we're going to be making today while going through this design. Once Andy has figured out once Andy's figured out the refractive index and dispersion, we'll be modifying the design a little bit. But first, what I need to do is I need to figure out how thick this is. 0.5 centimeter. I love how consistent he is with units. Oh, it's 0.098. Oh my gosh, okay. Inches. Alright, so center thickness, 0.098 inches. I imagine if I actually draw this lens out... Oh wait, okay, and now what I'm going to do is set the vignetting. Cool. No app. What's... Okay. So that's what the lens is looking like so far. That is not Very pretty. Considering that it's, one, not even coming to a focus. Let me just make sure that it's... Cool. Fine, we'll render from the dummy. Man, that is not nice. I don't like that. So what we're gonna do is we're gonna start varying things that can be varied in order to get ourselves actually designing things. So in optical design, we generally define things that cannot change and things that can change. In this design, the things that can change are thickness and radius of curvature. Initially, we'll get into, for ease of design or ease of manufacturing, we'll start defining consistent radii that will be grinded down to. But for now, that's all we really have. Ugh. Yeesh. Yeep. Yeep. Yes, Mr. Talking Machine, that would be very nice. I imagine a lot of people saw this and kind of glazed over it. Ooh, that does not look right. Okay. That's probably because I'm using 10 inches. Kind of want to turn this back to millimeters. Yeah, I'm gonna go back and do this in millimeters. We want an F number of 2, as I said earlier. We're looking for DFC. We're looking, it did not set my spectrum. There we go, DFC. We're looking to normalizing green, and we're looking for real image height next. Millimeters, because that's what I'm used to designing in. All right. Let's get these surfaces in. Dummy 1 and dummy 2. I need... we'll actually take this slow. We'll do one lens. We'll do one lens, start entering things later. More elements later. Because of how restrictive this is. And we're looking at, what did I say earlier? 0.0125? No, wait, we're in centimeters. So, a quarter of a centimeter is 25 millimeters. Okay. That's already looking a little bit better. So now what we're going to do is start letting the computer take care of designing some of this for us. We want to vary that thickness for 2 compositions. Let's see if that did anything. Cool, do I have to design this? By hand? I hope I don't. Oh, half a centimeter thick. So that gives me 50 millimeters. Regular surface 2. Let's see if I can get this for green alone, and then I will add in the other wavelengths later. Abnormal autocomplete scaled down nominal system can't be traced after missed at field. But I have one field. That's okay. Mr. Talking Machine, how have you been? Or how are you doing? Since you seem to be the only one watching. Dun 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 dun. Fields. Yeah, I have clear all vignetting. System. There shouldn't be any vignetting, so it's just missing. There we go. Alright. So that's actually catching my rays now. And now, there we go. Whew. This is in millimeters, right? Doing very well. Actually, right now I'm checking to see if I can bring more people over. That's awesome! That would actually be really awesome. Because I think people might actually enjoy seeing this. And they can ask questions about the process, how all this works, and I do not like that. I don't like that. Okay, time to add in some extra things. Extra lenses. Just gotta make sure I did that conversion right. I should have. No, I did not. That's actually 5 millimeters. I thought of it as 5 centimeters, not half a centimeter. Yay. Okay, so we'll go ahead and vary all these. NBK7 until I get the actual data. Right, and I need my stop. Alright, so this will help me keep some things in check. Okay, that's gonna look absolutely broken, but that's what I expected. Do. Okay. Okay, so I think I have to give this some more definition. But if I do this, that did not help. Awesome. Let's go back. Cool. Two. And I want this to already try to bring this into focus. Like I think we talked about doing a pets ball. I'm gonna double check that. Right. Okay, so we're looking at F2. I'd like to get us to 10 degrees. So I either do... But you actually agreed to collaborate with... No, so I have actually agreed to collaborate with Andy. I'm gonna kind of flash up our chats for the past, since October 29th. But I've got all the details. I sent him everything that I need in order to get this design done. So this is like a full-on, we're collaborating and working together on this. I know Andy's kind of, I tell you to ask Andy yourself, but I know he's kind of hard to get a hold of. Wave best RFO. Cool. So that just kept it right where it was. I imagine that's only get larger. Yep, because I don't have... Yay. Yep. That's exactly what I expected. Alright, I'll turn off slow mode. Let me figure out how I did it in the first place. Settings. Alright, slow mode's off. There we go. I did that in hopes that I'd get flooded, but I doubt that's gonna happen. But okay. So that brought me back to that. Okay, so there we go. Now we're starting to get something that might work. Except it's constantly expanding. Not coming to a focus like I want. It's coming into focus there. eval, EFL. So. Oh. Excuse me, I said an EFL of 85. Now I know why it wasn't working in inches, because I told it 85 inches instead of 85 millimeters. Now we're in millimeters. All of this will work now. Hopefully we'll see some more. Let me get my pop-out chat again. Wait, slow mode is on. I thought I just turned off slow mode. Strange. Why, hello! Welcome to the stream. Just designing some lenses here. And right now I have it expanding instead of coming out into an actual image. So I'm gonna just kind of back this up, back the design up a little bit, work back into what we need this to be. Set this as the stop. Now we've got just this. All right, there we go. We're starting to get an actual lens now. Okay. But this is absolutely ridiculous in size. So we're gonna start adding, so we're gonna add our second lens back in, because we're starting to get something that we want. And BK7, this is 0.5 centimeter, 5 millimeters. We'll start increasing these because we thought Petzval would work, and then 10 vary. And now this will absolutely break the design. Unless I take this to 60. It'll still, oh, well, ain't that nice. And sure, things are starting to fall back into place as they should. I thought what is this? I thought I did. Yeah, I have slow mode turned off right now. I might have to restart the stream. I'm gonna do that. Yeah, I'm gonna just go ahead and end the stream real quick. We'll be right back. And hopefully they'll turn slow mode off. Let's see if that's... What the heck is... What? Okay. Let's disable slow mode. Done. What is this? Slow mode is off. Alright, there we go. As all taken care of now. I'm sorry. Whoa, okay. Those reactions. Alright. Slow mode is taken care of. It should be gone now. We don't have to worry about that. Chat away. I'm sorry about that, guys. Alright. Alright, back to the design. Alright, so we now have a lens that's that's bringing the image into focus. And now's the fun part of waiting until we're getting minimal cycles. Actually, I might just set that to 0, freeze that, and see how that's shaping our lens. Okay. So now I'm going to take a look at this design, and so far that is very wide. If I do the actual conversion of centimeters to inches and actually do an EVA, eval overall length, so overall this is 232 millimeters. That is too big. That's about 9 inches. I don't think Andy would want to build something that's 9 inches long. All right. So let's start adding in some of the constraints that I had preset in my own head. So this is Mad Larkin. So this is a combination of both. I'm basing this off of what I know about portrait lenses from everything that I've designed in the past, as well as just kind of winging it. Because there's a lot of things that you can't just have pre-made, and just it's experience based, the winging it. The 9-inch focal length, it's actually not 9-inch focal length. It's coming to focus at 9 millimeters behind the last element, and that's not what we actually want. So I'm gonna remove this, and I'm gonna actually define what I want it to actually, the distance I want from that back lens to the image plane to be. So I was told by Andy that we have a baffled distance of 15 to 24 centimeters, and that's from the closest it can be to the farthest away. So I'm imagining I want my best focus for this to be at, let's say, 20 centimeters. So that'll come out to about 200 millimeters. Now, if I actually just set this to go, it's going to absolutely mess everything up. But we can come back to our auto program and just, sorry about that, and have this start to get everything focused better. All right. So what is this telling me? This is telling me that we have a double positive system, and that we don't want that. We're wanting a Petzval system, which is a positive and a negative, positive in front, negative in the back, and that we're kind of missing the point of this design at the moment. So get ready for an absolutely, nope, 65. Let's start working to get this better. Alright, so let's say I want 2 centimeter gap between each one of these at least. Freeze. We're just gonna go through this, see what that takes us. Alright. The semi-aperture is not horrible, especially for the blanks I saw Andy's made. I want this to come into focus. Let's see what the EFL is right now. So we're at 84.99. We're at 85, so that's good. Now the goal is to just kind of separate these out more to get a distance that we're looking for. sorry, to get the image in focus where we want it to be in focus. But it's not pushing it where I want it to be in focus. It's keeping it focused right there. Let's vary this and see if that'll help us out. Ooh. Okay. Yep. I think I pushed it a little too much. Might have to completely back up. Do you guys have any questions while I'm doing this? I'd be happy to answer them. Yay. Let me just pull up my Petsvol. Reference. This should get Andy a pretty cool bokeh effect. Oh, I might not be able to do Petsvol because it requires a doublet. So we might actually be going for a telephoto lens. Let me pull up what telephoto lens design looks for you all, so you can kind of get the picture of what we're kind of aiming for. So Andy doesn't really have multiple glass types, so okay, so Andy has made essentially this huge, what I'm going to call a blanket of glass. And he finally got it tempered recently. So I'm not sure if this was included in the video he released today. But we actually don't know what the refractive index is, the N. So right now what I'm doing is basing this off of BK7, or your classic glass. So this is from Schott, CHOTT, and their general refractive index is about 1.5. I'm going to be taking that assumption for now, and when Andy gets back to me about what the actual refractive index Monday is on Monday, I should be able to essentially refine this design back to what he gives me. So right now this is essentially a preliminary design, and we want to be going for telephoto because we only have one glass type to work with. So to do that, I want a positive lens, and then I want to bring back in this, and I want a negative lens. And then we've got 5, that can't change. BK7, very that. And let's give that about 5 millimeters. Okay. So let's see what that did for us. Absolutely nothing I wanted. Actually, we're gonna kind of cheapen this a little bit, make it a little bit easier on me. QRS telephoto. Oof. Okay. Never mind. Cool, I guess I have to kind of do this the hard way. Actually, kind of do some of this by hand a little bit. So, 10, negative 10, negative 10, 10. I essentially created two with equal focal lengths, so negative 5 and 5. That should change that. I want the negative to be much bigger, so let's set this to 20 and 20. Yes, I'm trying to keep the number of elements low because with each glass there's essentially a dispersion included with it. So that means that as the light travels through the glass, the different wavelengths will start to spread out. And if we only have one glass type, we can't essentially start to bring them back in. So if you know a little bit about glasses, we have flint and crown. If we have a flint glass, all the dispersion is going to go one way, and if we have crown, it's going to go the other way. And since we only have one glass, we want to keep that dispersion minimum, so less thin glass, less thin optics will help that out and help make sure that he has a decent portrait lens. And one thing that we haven't even gotten to yet that will be a big deal here in a second is refining all of these sets. Cool. Is making sure that we keep these radius of curvatures consistent. To make sure that that Andy doesn't have to build or make a whole bunch of grinding stones with all these curvatures. They're not grinding stones, but you get the idea. I do have the F number set right. Pupil image F number, yeah. Yep, I do have it right. You know what, let's set the stop back here. That way, all he has to do is essentially mount this thing to the front and we won't have to worry about anything after that. Plus, he could put something on the back that he can vary, maybe. It's up to him. Dang, how lucky are we as a species that the two common types of glass we had essentially corrected for chromatic aberration. Honestly, yeah, we could have. It's awesome that we were actually able to figure out how to make all this stuff with essentially no help, and that just multiple people, there we go, that's what I was looking for, were able to figure out how to make these glasses in such a way, these glass types in such a way that it all just worked out. Alright, that's not what I wanted. Alright, it's starting to break itself. Yay! But I'm getting the lenses I'm looking for. Kinda. And I'm getting the thickness I'm looking for. The only thing I'm missing now is the 200 that I was looking for earlier. Okay, so now we're gonna... No, I don't want to zoom. I want to freeze this. Okay, that should be not helping at all. Oh, okay. I see what's happening. I need to set this as a stop. I need to set this 200. Need that to be 0. Okay, that didn't help, but that will help my auto program if I back up far enough. Woo. Okay. How far back ago was this? Okay, there we go. So I said use the stop surface. I want to freeze this. I want this to be 0. I want this to be 200. So I'm defining this such that I stick my back surface of my lens onto the wood. From there, the 20 centimeters, it should take the 20 centimeter from that surface to the 20 centimeters to focus. Which it doesn't, because I have a overall positive power to the system. Sorry, overall negative power to the system. Which means that I need to increase the positive power here. Not that much, apparently. And this will overall hopefully start to bring my system back into focus. Excuse me, I actually wanted 25, not negative. Okay, so I have the overall powers that can't be traced because nothing's going through. Of course. Okay, so it's liking that front surface. Yay. Still not liking what I'm doing. I know this looks like I'm just kind of jumping around like, oh no, why isn't this working? But this lens is overall very different than what I'd say most optical engineers are actually used to designing. We're used to just being able to say, all right, let's vary everything, and then just throw in some numbers here and it'll get to where I want it to go. But I can't do that. So, all right, I'm going to do some handwork here, and I'd love to show it to you. Actually, I can show you what I'm referencing as I'm going to talk all this out. Oh, that's not what I wanted to do. Yeah. So we're going to be fantastic. Oh, snap. Sorry, got lost in my own thoughts there for a second. All right. Mr. Todd, I was told not to do that by one of my engineering teachers. I used to do things by letting myself have a lot of leeway and then adjust, but he insisted on calculating things precisely. For certain applications, I can see that, but let me try to explain lens design the best way I can. Imagine this. That's not what I wanted. Imagine erasing all this. Imagine this is the realm of all possible lens designs based on how many variables you have. Let's say this is 2 variables. And these are the different, it's essentially a topographic map of possible designs that you can go into if you've gone into, not Fourier, if you've gone into calculus, these would be your essentially a field map of possible designs. Let's say that I want a design here. This is where I want to end up. If I start at my green spot here, and let's say this is what I calculate. If I don't, let's say, vary 2 more radius or 2 more radii, then I can't get here. Or if I vary something wrong, I could end up this way. So it's possible to do things very precisely, and I could show you my ability to do the handwork for all of this. But honestly, it's pretty boring if I were to do that, and could end up being a waste of time. I can do it for starting, which is actually what I'm about to do right now. And sadly, I can't fully show. You know what? Here's what we're gonna do. I'm gonna pull over Excel, and I'm gonna show you what I'm gonna do. Kind of. Lens equation. I think this is it. Oh, I don't want to use that one. I want power. I'm trying to get you a good reference picture. Hold on. I've got a field guide on my phone that actually has all the equations that I actually need. Basic concepts. And if you were an optical engineer, this would essentially be your hand guide to everything. So I think the equation should be 1 over f is equal to 1 over phi 1, 1 over phi 2, 1 over z1 minus 1 over z2, or something along those lines. But it's just essentially saying that it's a lens equation, and it's like image this way, however far the object is this way, plus however the object is this way. But that's not what I'm trying to do. I'm trying to do the full equation of multiple lenses. But honestly, I don't want to do any handwork today. You know what? We're just gonna add some positive. We're gonna have positive power here. We're gonna have negative power there. We're gonna see. It still doesn't like this. Why are you not liking this? -15, -15. Alright, you're liking this, but you're coming into focus really soon. So, back it out again? It's like the best option I have. And we'll see where the program decides to take this. That was fast. And it's still bringing it to focus too soon. Maybe I'm being too demanding by telling it to focus at a 200. Or maybe I just need to add a constraint to force it to do that. Hold on, I saw your question. Just give me a sec. I need to get my prompting guide. This is my hand guide for this program. So I'm interested, what problems are you or other optical engineers asked to solve on a day-to-day basis? Does it usually involve specialty lenses for manufacturing? I imagine it's not all camera work. You're right. But on a day-to-day basis, if you're in lens design, that's one path of optical engineering that you can take. Yeah, we have the possibility of doing illumination, data transfers, which is kind of imaging, but it's not really. In fact, in terms of illumination, oh man, this is one of the things where I kind of wish I had an iPhone, but I'm kind of glad I don't. So the flash for the newest iPhone, I actually had a Apple engineer come and I had a talk with an Apple engineer about how they designed it for the iPhone X, and it was really interesting how they did that, how they had to do that challenge between the science and the artistic side. But generally what we're asked is we're given a list of specifications. So if you see above, those are the specifications I have for this design. And we're told, make the design. There's things that we have to take into consideration, such as modulation transformation function, which I'll get into once we get to that point in the design. Athermalization, meaning between a certain temperature range, how will the lenses shift and how will they warp and bend, because of thermodynamics, that is a problem we have to take into consideration. And size constraints, cost constraints. Yeah, optics is quite a challenging field, I will say that. All right, so let's look up my auto function stuff. Okay. Does that make sense? Am I coming across well? Derivative increments, no. Okay, error function. Use centroid. I don't want to use centroid. Minimize wavefront. Sab, no. I don't want to wait. I don't want to do through focus. Don't want to do MTF. User defined error function. No, that's not what I'm looking for. I'm looking for the constraints. Here we go. No problem. I'm glad to help. I know quite a bit. I've been doing this for a while, and I can even tell you about a couple of programs if you're looking for colleges of where you can go and what you can do with that. If you want to get more into it, I can even share some books that might help. Glass map. I don't want to do the glass map. Alright, here's my EFL. So I essentially have all of these little program things I can do inside of this overall lens design program, and I'm just gonna start making an actual program that will allow me to come back and define this a little bit better as we move along in the process. And right now it's just trying to make sure that we're getting the 200 millimeter focus that we want. Okay. Image distance. So I can actually say there we go. This is what I was looking for. So I'm going to be using the command imd is equal to 200. And imd, by this book, it says the image distance plus the defocus. So that means how far is the distance from some element to the image. So I'm going to set that back to 0. I'm going to freeze that. I'm going to set this to 200. And we're going to try out this command and see if this is actually going to work the way I want it to. There we go. It does exactly what I thought it would do. Now, well, it's getting it better. Oops. So we should be seeing this increase, but it's not exactly. It might be going towards this value 0e to the 0, 8.5 difference. Thanks. Alright, so now we have to provide weights for each one of these. So, sorry. So now that we know that this isn't moving the way we want it to, we're going to add a weight to this. And that should be WTC if I remember correctly. Come on, where's the weight? I know it's here somewhere. How are you guys liking the music? It's just something that I randomly found online. That should be not copyright free, so I can post this video, so I can edit this video and post it a little bit later, or modify some parts of it. Let's set this a weight to 1. And we'll set this a weight of 0.1. And we'll see how that does. Alright, it does not like that. Okay, it's ignoring those. Is it a comma? I'm trying to remember how to use these, because I haven't had to in a while. Okay, it's being ignored. Still. And this isn't very clear about how to best use these. Yeah, wait on prior constraint. What is happening? I've done this before. I know I've done this before. It's not like I'm trying something new. My main concern right now is how will the lenses be actually crafted, wondering if Andy will be able to make them precisely enough to make a multi-element camera lens usable. That's another thing that I'm working with Andy to try and get sorted out. And I'm trying to do everything in my power to make it easy to manufacture. Right now he's looking at, what is it? Battens, and using essentially a lathe to grind the lenses down to their shape. Let me pull up the reference that I have of what he's trying to do. So essentially what he's doing is he's taking the lens. Let me zoom in on this picture because it's really well. Okay, can I just open that image alone? All right, perfect. So if you see this picture right here, imagine sticking your lens blank. I'm just gonna use this tape for example. And we have essentially what we call a batten over on top of it. What we're going to do is we're going to stick some weight on top of that batten and have it putting pressure on the glass itself. Then we're going to spin the glass and essentially start grinding in the radius of curvature on it. And there's another element where we're going to have it go this way to try and take care of some other, have the batten go across the surface like this, so as to reduce some possible manufacturing errors of just leaving it straight like this. So I made sure that talking with Andy that was the route that he wanted to go, especially considering how he made his telescope a couple months back, I think, and how he was essentially not able to get really good pictures or a really good image out of it. Yeah. But I'm making sure that I know the pitfalls he can go into, and I'm trying to make sure that we don't go into any of them. And that's the big thing right now. Okay. So it's not liking my weight. Yeah, same here. Alright. We're gonna cancel this and use the UI to figure out how to actually do the this. Oops. Whoop. That was a noise. Okay, effective focal length. Optical design. minimize weights. Let's make this 0.1. And then we're gonna figure out what they... minimize, apply and close, nope, nope. Save and load. We want to preview WTC1. Okay, it was the equal sign that was breaking it. Cool. Good to know. Good to remember that. There we go. Okay. So that did not do much. But we can always modify this so that way it will want to do what I want it to do. But I think at this point, overall, I'm just hitting a wall because we have one element. So I think now it's time to add the second element back into the system after, what, 30 minutes? Just keeping them different. We're gonna split this up, so 75, let's make this 25 and 50. Woo! That does not look pretty. So let's undo that thickness change there. And we're gonna vary this and this, set that to 10. And let's get this going. That is 11 millimeters. Oh, you mean the big guy? Yeah, yeah. That was that is something we do not want. Yeah, that was not something we wanted. All right, so let's start bringing this down to 50. We're still coming into focus, which is good. Huh, it's like it's still ignoring me on how far away I want this to come into focus. Wow, it really is just ignoring me. They're saying, I know exactly what you want to do, and you want to come into focus as soon as possible. It's like, no, I don't. I want to come into focus after a certain distance. Kind of want to just do 200 and then see what it does. Ooh, that is... Hey, do you guys want to make a lens that's half a millimeter wide? Sorry, a millimeter in radius. The answer should automatically be no. 5-inch diameter, 2-inch thick glass monoconvex lens I pulled from an overhead. You guys want to see a really big lens, and I mean a big lens. I've got it here in my room. I can bring you a giant lens if you really want to see a giant lens. I'll let, if I see a couple people go, yeah, let's see it, then I'll go grab it. It'll take me like a minute. So I see one. Anyone else? You know what? Actually, one person's enough. I want to introduce to you my lens that I call Big Bertha. So, this thing is about the size of my head. Oh, nope, I don't like doing that. Yeah, this thing is pretty massive. I would actually estimate, yeah, this thing is huge. Ugh. And it's I actually got it for, so that is a, oh gosh, I've got the lens description on one of its wrappings. So this is a quadruple condenser lens. I think it has an EFL of 165. And I don't know. It wouldn't really be for a telescope. Oh gosh, what would it be for? That's actually a really good question. I have no clue what that'd be for. I know I designed some lenses for the military that were, I don't know, maybe that size. And boy, I cannot tell you about how expensive the blanks alone, like just the pure cast lens blank was, but whew, just one element alone was a couple thousand. You're right. Generally for light dispersion they use Fresnel lenses. And what's interesting is that's a quadruplet, so that means there are 4 glasses essentially. Sorry. Four lenses or 4 glasses glued together while they're being shaped to reduce dispersion. So overall, this is just honestly, it might just be like a really specialty lens for some company who needed this at some point. You know what? I think I'm going to start adding some new fields, because I think it's just seeing the 0 order and saying, all right, oh, any idea when it was made? So it's actually an interesting story how those lenses how that came into possession of that lens. It was the University of Arizona actually received a whole bunch of lenses from some company that went out of business in town, because the lens I have is over 50 years old. Okay, I know it's not that old. This lens is probably, I'd give it in the ballpark of 10-15 years. We're looking at 4-inch by 5-inch. I think it's 5-inch vertical, so let's start working this in at 1-inch. This stream category is gaming? Is it? Oh, it is. That's my bad. I will change that to education. I didn't notice that. My bad. iteration failed to converge to XRI, YRI. Alright, so let's change this to oh right, no, I can't do real, I need to do paraxial image height. If you didn't hear, that was doing a rockabye baby. Oh wow, okay. Crud. I don't think this lens, it was ready for this. Okay. I probably should have started with defining my field first. Cool. We'll just do that then. It's like I'm having a, what is it, athletes call, what, performance anxiety? It's like, I know exactly what to do, but I'm just getting bogged down because I'm not used to showing off my skills to an audience. Can you not hear it? Oh, I don't know, it was some channel called Audio Library Music for Content Creators. It should be all free to use. I hope it is. We're sticking with millimeters. We're just going to call this. All right. Yeah. It'd be nice, to say the least. All right, so we want the stop at the last image. Right, we need 4, we need dummy, excuse me, type dummy 1. We want dummy 2. We want this to be our stop. We want to just start going crazy. Thickness 5. 10, 10. 10, 10, 5. Something around those lines. Nope, that's not what I wanted. I did stop. I actually didn't want that either. Wanted this one. Operation not performed due to ray trace errors. Makes surface apertures oversized. Yeah, well, I can't control the surface aperture, so... Woo! Woo! What are you doing? Jeez, that is way too small. Okay. We're in millimeters, so... There we go. So that's starting to actually give me something. No improvement possible. Oh. Why can't you just figure out what I want it to do? Okay. Missed. All right. So, one. Why is the an X? Alright, so that means that my on-axis is doing what I want it to do, but my off-axis ones are just going absolutely everywhere. So let's go ahead and take out the image distance and just make sure that we're getting something out of this. Alright, that's refining it a little bit. Maybe F2 is a little high for this system. I think he said F6. I might refine this back to F2 once I'm done. But I think this will allow the system to... I think this will give the system more flexibility. Yeah, there we go. That gave the system more flexibility. Alright. So overall, now I'm starting to get a design that's working. Okay. Let's work in our next surface. We want this to be the stop this time. We have a positive lens and we need, ooh, I'm hiding the chat. Okay. We have a positive lens at the front. And now what we need is a negative lens. Come on. Because we're doing telephoto. Wait a minute. We need to do a reverse telephoto. Maybe? Because if we do a reverse telephoto, which isn't something that you would normally want to do, but this will increase our back focal length. Oh my gosh, I'm an idiot. I'm such an idiot. Oh my gosh. So, I can't believe I didn't do this. So what I was looking for was a back focal length of 200 millimeters. But I've been telling it give me an EFL, an effective focal length of 85. So, and that image distance isn't what I needed to do. What I needed to do was BFL, which is the back focal length. Either that, or I needed to do something along, be more clever, and I needed to define the distance from whatever, I think I'm SS to S6 to be the 200 millimeters I was looking for. Cool. Alright. So now what we can do is we can do an OAL of SS dot S6 is equal to 200. Is equal to 200. And now this should hopefully find it. Okay. What the heck? Are you sleeping? What is this? Turn this up a little bit. Okay. Dut, dut, dut. Error expecting that. Interesting. But it should be recognizing that I'm typing SS and S6. Which I've done before. And so overall length of surface, what? So let's change it S5, S6. Let's see if that helps us. OAL of S5, S6 is equal to 200. Cool. So we're doing the old trick of looking back in the automatic design and saying manufacturing and packaging, overall length. We want to start at the stop, and we want to go to the dummy. We want to constrain this to equal 200. Apply and close, save and load, preview, and this is what we were looking for. Though I think that's what I was typing. If you think otherwise, please let me know. I think the only difference is the Z1, but that's defining my zoom, and I don't have different zooms. So normally I should have just been able to leave it out. Okay. This probably isn't going to do anything. Yep. Aperture and field missing rays. Go real ray image height iteration failed to converge. Zoom position 1 is an alternate image specification. Okay, what I want this to be is let's just give this some power. Hope that we haven't broken it yet. Cool, that breaks it. That should hopefully put them in between. Yep. I imagine that this is not liking my other fields very much. But if I just comment this out and work with just getting a lens to work, it's like it's not touching any of these. Alright, so that's helped my vignetting, but it's still saying that's missing chief rays. And that it's missing to converge wavelengths, fields. vignetting. Alright, so now that I have all my fields back, this will start to refine the design. There we go. Whew. But those are close together. Alright. Now let's bring back in this overall length and see if it will actually take to it. 19 cycles. I like that. I like that. And here we go. We finally have progress, and now I can finally move fast in this. All right. So, yep, this is a reverse telephoto. So, okay. If you're still here and you're still watching, we're finally making some actual progress on this design. We're actually getting where we want to go, which is getting our 200mm effective focal length and getting our image height where we want it. So if I redo this, it's going towards a reverse telephoto. This one's this surface right here on this back is wanting to go to being plano. We're getting some differences here, but I can work on that. All that's left now is to work on my fields to get everything back to where we want it to be. Now, I'm gonna tell everyone about a little technique that we like to use in the optical engineering business, which is a zone of best focus and everywhere else. Oh, I broke my book somehow. Okay. So, when we're doing an optical design, you have to take into consideration where people are going to be looking. Are they going to look everywhere? Is it going to be what really matters in the image? For a portrait picture, you generally want of course you want the center to look great, but as you go towards the edges, how much image quality are you willing to lose? I'll take care of that later. How much image quality are you willing to lose? So here's what I'm thinking. We're going to go to Paint to demonstrate. Sorry. We're going to go to Paint to demonstrate this. So let's say this is our 4x5 image. This is just the size of the image that we'll be working with. Now, let's say this dot right here is the center of our image. We of course want that to be in focus, but now we need to look at how much of the rest of the image we want to have a good focus. So let's say that we want this section to have good focus, and the rest, if it kind of wanders off a little bit, that's fine. Now what we're going to do is define these dimensions. If it's a 4x5 inch, let's give this a 1 inch margin around. So ultimately we want a great focus of a 3x4 inch image, and we can lose some quality in the remaining parts. So we're first gonna work up to this 3x4, and then after that we're gonna work up to, we're gonna add fields on top of this to work up to this 5x4. That makes sense? Yes, no. Are you still here? Whoo, hoo, hoo. If the lenses are radially symmetrical, wouldn't the region of best focus be a circle? Yes. Yes, you're right. It should be a circle. I'm defining it as a rectangle in my head because we're working with a rectangle image. And when you will think about, and when you look at the picture, you'll think about things in terms of the rectangle. But overall, it will still be radially symmetric. Granted, I could, if we had the capability, design it so it wasn't radially symmetric, but we're not. Well, we're not going to be worrying about that, because that would be way too much effort for Andy to do, and I do not like this. That is way too big. Well, let's take it and see where we go with this. And if anything, I'm just defining points where I can analyze it right now. This is only going to get worse. Ooh. Okay. Okay. It's not liking something, so. Okay, real image height iteration failed to converge. Okay, so we're coming back into the problem that we were having earlier, but kind of killed some things. So let's bring this 300 and see what that does. Okay, okay, there we go. And I have things in real image height. Okay. I don't like that. I do not like that at all. I might add some more elements. Because that... Oh, wait, no. Because I do not like the shape of that lens. In the slightest. I don't like that. Right. I know what's happening. So this is... So Andy won't actually be able to make this lens. No. The lens is actually completely capable of being made. The only problem is evaluate the edge thickness, etc. S2.3. So the main problem is, while the distance in between here and here is 5 millimeters, the distance between here and here isn't 5 millimeters. And that's what we're constrained to. here to here needs to be 5 millimeters. So what I need to do is I actually need to add a new constraint into my window. Analysis, automatic design. Because I don't want to pull out my book, we're just going to do it this way. So manufacturing edge thickness needs to be 5. What? Preview. Edit. Okay, so I have to define at the front of each surface. Got it. So preview, ET. Really? Is that actually the thing? I don't want that one. Viewing and plotting, interactive 3D, constraints, general constraints. Optical definition. Okay. It is ET. Okay. And I have to define it at each surface. Okay. Got it. Got it. So now what we need to do is do ET is equal at, what are my different surfaces? Thought I just heard something. So the ET at 2 and 4. S2 is equal to 5. And ET S4 is equal to 5. Okay. So this should be helping us to refine our design some more. And let's see what this is looking like. Ha 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 ha. Woo! This guy is not happy. He is not happy in the slightest. This is not, it's not happy with what I'm doing. Oh my gosh, it's not happy. So the reason I know is because this is 101 millimeters in radius, which if I just, that's a 4-inch radius, so that's an 8-inch lens, and it's still not capturing what I'm wanting. Yeah, I think we'll rain down back, come back to 2 inches and see what, and refine this and build back up. That would definitely be a weird looking camera. I do not disagree with that. Okay. Okay. That's probably not what it's looking for, but that is bringing it into a more reasonable sense. Okay. It just broke itself. Yep, I noticed that. It broke itself on the second to last one that we did. Ah, that's why. Whew. I don't even want to actually do a real analysis of what this is, what this image, what the imaging properties of this would be right now, because that is disgusting. Alright. So both of these are not coming into focus how I want them to, how they were earlier. They're kind of just getting stuck at this second lens, essentially. So let's bring it back to 25.4 and work all the way back. Maybe if I include the overall length, it might say, oh, I've got room to actually bring this all into focus, which it's doing exactly what I thought. Cool. It's still not happy with me. Still not happy with me. Go back to here. Okay. This guy's pretty happy. I think if I set this one back to 25.4, it might start refining it the way I want it to. And it did not. It's really strange. It's liking this design, but it's shoving the lenses into each other, which it shouldn't do. So that means I need to define MNT, which is the minimum distance between everything. Back to the book. It's like MNA and MAE. MNA. Oh, and MNE. Yeah, it's like, I don't know. I mean, I'm pretty sure if I try really hard, I can get my hand inside this microphone. Alright, see you in a bit. That broke it. Yep. Because they were invalid. Spread your cheeks back out. There we go. That went through 23 designs. Okay. I think it broke itself. Okay. I'm going to have to take this really slow. Oh, I wish I had saved that initial design. That was working well for us. We're going to put essentially a safe spot right here. Okay. MTE should be, sorry, ET should be defining. Oh, I know what I need to do with this. It should be less than. Should be less than. That should help us out. Because that is saying as long as it's less than, then we're fine. And this is a vignetting problem. I think we're getting somewhere with this. All right, we're getting somewhere with this. We are getting somewhere with this. All right. Back to going to 50.8. And time for it to break. No, okay. I may have actually gotten to the point where the design is working itself out. Now, this should break it. And if it doesn't, we're in business. We might be in business, folks. Folks, we might be in business. Now, I want to see what the 3D is looking like. So they're not even really coming into focus at that. Well, since that's the case, what we're going to do is we're going to back this out. To there. Because that was before I started introducing the... There we go. All right. So. Okay. Building it back up. That's what we were working on. 76.2. Not yet. There we go. And these numbers are actually looking pretty nice. I think we have a design on our hands. I think we have actually done it. There we go. Okay, we're looking for 3x4. So 4 is 101.6, and 4 is our lateral height, so... Set vignetting. Okay. And these are actual lenses he can make. Those are pretty good clear. Those are pretty good semi-apertures. I think we actually have done it. I think we've done it. Oh, I'm excited now. System data. All right. Here's where I was hoping I would get to by this point in the day. Or earlier. So, we need... So, these are our good fields. Oh, I've got a lot of 3D views. system data. Okay, X, that's 4 inches, and this needs to be 5, which is 127. Okay. So I apologize if you heard that. Apparently someone banged something. Okay. So everything is essentially coming into focus. I'm going to define the surface properties aperture of the image. I'm going to do X semi-aperture. So that's 2.5. No, that's 250.8. Delete rectangular. X is 50.8, and this is 2.5, and that's 63.5. So now if I redo this, oh, well, it looks like I designed this too well. I designed this for something that was twice as big because I forgot to have everything. So I need to go from 2 by 2.5 semi, and I need 1.5 to 2 inch semi diameters. So I went a little too far. Honestly, I'll take it. I will. I'm glad that it works that far. So this needs to be, I need to be 63.5. This needs to be 58, right? 50.8, 50.8, and this needs to be 1.5, which is 38.1. Okay, so adding, I don't want to do it that way. Set big. Set big. Okay, now everything is coming into focus. Let's look how our lens design is looking. I'm pretty happy with that. Now we can do an actual analysis. So, MTF. Woo! Oh, never mind. Oh, gosh. Oh, oh boy. Okay. I do not like that in the slightest. Ouch. Ouch. Diagnostic distortion grid. Ouch. Woo. Welcome back, Mr. Talking Machine. We have an actual design, but it is not looking pretty. Let me show you with an actual image what I'm talking about. We need to change this to... So let's say we're looking at this landscape. Object, image. That's not pretty, but we can adjust this some more. We have an actual working design. That's what's great. Oh, I haven't even checked out the color. Oh, okay. All right. Show me how bad this gets. Oh. Okay, so color's not a huge problem for us. I'd say overall that's pretty good color. But we're having a huge amount of distortion, and that's something we want to reduce. But a bigger problem comes in that we're only focusing 6 centimeters away, and I was told that the minimum is 15 centimeters. So let's first try to bring in something that's 15 centimeters. Whew, all right. Okay, I'm kind of scared because I think this might not do what I wanted to do, which I'm right. Let's see if BFL is an actual thing. ABCF, no, back focal length is not a thing. Okay. So let's think about how to actually do this BFL. Back focal length. Because I can do EFL. Pretty easy. Oh, okay. Since that's not... Let's see what happens if I actually push the stop to be there instead. And I have this vary. Let's see what it does with that. Nope, 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 nope. Oh. Nope, nope, nope. You're not allowed to do that. You're not allowed to do that. Okay. So it doesn't want to stop there. It likes to stop right where it is. So let's actually set the stop there. See what it does with that. Okay. So it's setting us to 58. I'm not liking how those are really working out. Okay, so we're 150 millimeters away, but it's not bringing our focus to 150 millimeters, which brings us back to our problem of we need to do a BFL. Okay, so let's try and figure out how we're going to do BFL. Because all it's giving me is effective focal length. I think I might actually need to go back to doing IMD. Let's try that. It did nothing. Is it actually... IMD. Okay, so it's taking the constraint into account, but it's not doing anything about it. Overall length. No, we don't want that. We don't want to do the semi-diameter. We don't want to do blocking. Image centroid. Not sure exactly what that means for this program. Reduction ratio, I don't want to do that. Total track. Don't want to do that. Image surface clearance. Let's try that. I mean, nothing wrong with actually trying any of this stuff right now. Because right now we're still way below what we should have. Actually, you know what? You know what might actually cause it to radically change? Changing the F number. Okay, this is starting to get us closer to what we want. Tell Andy to make somewhat curved piece of glass and try and make it work. Should we just tell Andy to make somewhat curved piece of glass and try and make it work? JK. I wish. Ugh. But nope, we cannot. The goal is to make an actual camera. And I'm actually down for it. This is like a free day for me. Or a free weekend for me. And I enjoy doing this sort of stuff. That's why I get paid for it. I think I just need to increase the EFL. I was like, what? 135 was the other good portrait lens. Who knows? Maybe he'll nail it, if by accident. Hey, if we have good engineers helping him out, I'm pretty sure that Andy will be able to do anything. Yeah, I think I need to increase the EFL. Because that just shot us up to 95. But at the same time, I want to be at F2. And this is... Yep, that broke it like I thought it would. Because it was too radical of a change. Cool, it didn't even like going to F3. Cool. Let's just... .5. Okay, that worked it out. What? These rays are missing. They're still missing the lens entirely, which isn't good. But overall, I mean, we don't have a horrible design. This back lens here is actually really nice in that we're having somewhat concentric radii. So later what I can do is I can freeze this and send it to 25, send both of them to 25, and then have the auto function run. Having an F number of 6 is actually, it's helping us, but you would think that it doesn't. If we actually took it to a much farther extent, it won't. Oh, you mean the before I modified it? Probably. Yeah. Well, it was 24 and 21, so it was almost trying to be concentric. You're right. It looked like it was. So having a higher EFL is helping us. I kind of want to see what the MTF looks like now. It's probably horrible all the same. Whew, jeez, I don't want to think about that. I do not want to think about MTF right now. You know what? We're not going to analyze it based on MTF. We're just going to look at the 2D image simulation and the distortion. Okay. I think we're starting to hit the nail on the head about distortion. Distortion grid. Yeah, that's not as bad as it was. So that's nice. Let's see if I bring the F number back and run our auto function. What starts to happen? Set vignetting, that should theoretically open this up. So imagine that we're gonna have really darker edges. Hey look, it's about the same. Oh no, that might be nice. Let's consider a portrait of a puma and see if we can, we'll take that into consideration. Let's see what we get out of it. Oh, I hope this isn't causing lag. No, we should be fine. Not bad. That's not bad in the slightest. Yeah, that's not bad. Though we're still running into the problem that we're focusing too far away. So if we were to say that this back lens was stuck onto the wood, we would have the problem of we're not able to get to the image plane. So if I move this to be solve delete solve freeze 0. Let's say what this is 88. 112. So if I do this 2D image simulation again, taking into account that that's where I want it to be at best focus, I can do 150 minus 88. I'll show you what it looks like, and it's not pretty. 75%. Oh. Oh. What? Well, okay then. That is that is a pleasant surprise. That is definitely a pleasant surprise, I will admit. Oh, hold on, that might actually be too loud for you guys. Turn that back down. Okay, yeah, no, the 2D image simulation says it works, so I guess we, for the most part, have a good design. All that's left is to refine some things. Okay, so with this, he'll have to make 2 bands. Sorry, he'll have to make 4 bands. We need to reduce that. You know what? I might actually just do this off camera. But for the most part, I've showed everyone the general idea of how to make a lens. Let's try and get our F number back to the 2 that we have specified up there. What do I have it set at? We'll see if this ends up breaking it. It might. And if it does, we'll just kind of undo what we did. I'll work on refining it later off camera, but we've got a lens, boys. We've got a lens. Well, we've got a lens. And it's getting us generally good color. I'm impressed. I'm honestly impressed. Now, we'll have to wait to fill in the actual glass later, and there's obviously some things I can do. I might add some. You know what? That's what we're gonna do. We're gonna add another element. We're gonna see if that will help us out a little bit, because the chromatic's looking good. That was my main concern of keeping it to 2 lenses, that our chromatic would look bad, but it's not. So I kind of want to see what I can do with this. First of all, but before that, save. Let's save this. Let me make sure that. Okay, this should be our standard lens that we have ready to go to redefine later. So, oh, but I might be crashing. So, we have the option. I'll put this out to you and whoever else is still watching. We can either keep going with this, try to make this better, or we can end the stream here and I can work on this in my own time. I'll let you guys pick that up as your own, as a vote. I'll wait for a couple of responses before I move forward. Do you want me to keep going? Do you want me to end the stream? I'll do a follow-up video, or I'll do a video talking about the analysis of this, and it'll go up on my channel later. Not today, of course, but closer to the time that Andy will be releasing his video. So, the option's up to you guys. I'm good with either. Though I will say I'm getting a little bit tired. Whew, been going for 2.5 hours of struggle to get this camera to work. But we have results, and that's what's fantastic. All right, so we'll be ending the stream there for tonight. I've done enough to show you guys what some of the stuff that goes into making an optical design, given the constraints, given the massive amount of constraints that I have for this design. Thank you all for joining, and I'll see you around next time. Bye.